Okay, on the workbench we have a Sony ICF6800. This was a fairly popular shortwave receiver way back when. Very innovative. So this is a quick overview of I've actually pulled it out of its case and just given it a quick check over before I start the repairs on this one. They're not that easy to work on. I've repaired a few of these over the years, and you sort of get a little bit better at it as you go, but they're still a pain in the arse basically. But however, I'm just looking, there's no signs that it's being interfered with, which is a good thing. I really hate repairing stuff that other people have looked at. The internet's a good thing in one way, that it gives you lots of information about this stuff, but unfortunately many people tackle these jobs which are way in excess of their actual abilities to do so. And I've seen some horrific messes over the years, to the point now where I absolutely refuse to work on stuff that other people have had a go at. There's just too many faults, too many faults. So as I say, these aren't a great performing set, contrary to what the internet would have you believe, but they're fairly iconic, and for that reason they probably are worth spending a bit of time on to repair them. But yes, it can get quite involved. There's no visible signs of anything majorly wrong with this one. As I say, I've taken it out of its case, and which is a fairly easy thing to do. The main hassle with these is actually working on the circuit board. The wires are barely long enough to allow access. But where there's a will, there's a way. So I'll remove the power supply, because we won't need to work on that hopefully. I've hooked up a temporary speaker there so we can actually turn it on shortly and just see what it does do. So let's do that. There's nothing lighting up anywhere. We've got noise on AM broadcast, and we've got a very distorted signal on FM, and that's a classic sound of shorted or open output transistors. There's also no display. There's no dial lights. That's a common thing with these older radios. That way it concerns me, there is no digital display at all. Nothing. And there's no sound on shortwave, where the meter appears to be working, showing something. I don't know if you can hear that or not. Just so I would say at a first guess that this thing has either had the power put on backwards through the DC socket, or the power's been connected the right way around, but it's been too many volts. Probably been used with a 12 volt battery perhaps, I don't know. But I'm happy to see that there's nothing visible to say that it's been butchered or other attempts have been made to repair this. So for that reason I think it's worth continuing with. So what I'll do first we just follow the faults along. So first off we need to find out what this audio distortion is. Well, before we pull this apart, I'll just go through a few things here. This here is the audio board. Bass, treble, volume controls here. Bass, treble, volume. The other two output transistors there. We've got a driver transistor here, another driver there. Now we've got a dodgy looking capacitor right there. Looks pretty munted. Don't know why it's so deformed, it almost looks like it's been squashed at some point. Yeah, as I say, there doesn't seem to be anything else. Now this is the FM section right there. This is a fairly rudimentary FM receiver. Just uses basically a mixer, oscillator, couple of transistors, and it's a separate entity. The FM section shares nothing common with the rest of the setup and the audio amplifier. Now if we move along to here, we have the, in trouble with this camera, that's the VFO for a single sideband reception. We have a fairly rudimentary IF filter right there. Again, I've lost the camera, there we go. This is the, under this can, there's just a fairly rudimentary entertainment type radio on a chip. I can't remember the number of it now. But that's used as a second IF, which is at 455 kHz. And we've got what I think by memory is an 18 megahertz first IF. We have here a broadband transformer. And these ratty looking wires here are the oscillator in. Yes, the oscillator in to the mixer. Here we have, this is the guts of the system. This uses a variant of the Wadley loop, which was used in quite a few receivers back in the day. Noise, drift cancelling loop. The most famous one I think is the ICF6800. What people erroneously think on these is this switch here, which is actually not a switch at all. If you notice here, that is a 4-gain airspace tuning capacitor, and this, what feels like a switch, is actually just a plastic indent. So we divide the tuning capacitor steps into 10. If you remember, the FRG7 had a megahertz tuning knob, and you used to twiddle it, and a red LED came on and off when it was presumably on the correct frequency. This one here doesn't bother with that, it uses indents on the tuning capacitor. So obviously the people on the internet that tell you it needs a spray and the switch cleaned is certainly not the case. Under this can here is the high frequency VCO, which is part of the synthesizer setup. There are 4 coils down in here. These are the offsets for our band switch, which is this switch here. Sorry, that one there, and on the outside of that is another switch, which I can't turn it now because I've taken the knobs off. But we basically divide bands 10 megahertz wide, 10 divisions, 10 megahertz wide, times 3 positions on this. So that gives us our full coverage from 1 meg through to 30 megs. Sony was actually quite innovative as well. I've got a lot of time for Sony, to be honest. They're very, very clever in their designs. If you're going back again to the FRG7, Part of the setup or tuning procedure was to tune the front end pre-selector. This involved a switch which had 4 positions and a tuning knob. Well, Sony have gone one better than this. They've actually made up a wee unit here, which I'll show you if I've got to open it up later. In fact, it does look like it's been desoldered at some point. It certainly doesn't look factory to me. But however, yeah, this here tunes all the way from, if you have a look here, I'll swap hands with this camera. It tunes all the way from, where are we? God, I keep getting lost with this thing. From 1 meg to all the way through to 30 megs, all in one go. And this is quite an achievement, and they're pretty cunning, Sony, very innovative, as I say. What they've done, they've got a tunable inductance, which is gang, there it is there, I don't know if you can see that or not. There's the tuning inductance, and this is coupled with geared to a normal tuning capacitor. So at the high frequency end of the band, the core of the coil is right out, giving it a low inductance, and the tuning capacitor is wide open, giving it a low capacitance. So that would be the high end of the band. As the two work in unison to each other, we can tune all the way down to 1 megahertz to peak up the front end. This simplified the set considerably. But as you can see, it's a real pain to work on. A lot of the subsections are in these little sardine cans, which require them to be opened up. But basically, I'm going, at this point, I'm not going to worry about anything else other than get the audio sounding a bit better than what it is. And I think we'll just work on one problem at a time until eventually the set becomes fully functional, if it will. I'm a bit concerned though about the frequency display. That should actually be working. And we're on AM, either AM or FM, AM or shortwave. I only hope the reverse polarity or the over voltage has not damaged it to the point where it cannot be repaired, because obviously parts for these things now are, although they use a lot of generic parts, the frequency counter section is pretty much special Sony parts. Okay, I'll leave it at that and we'll see how we go.